In this section, we're going to focus on the trigonometric functions working with right triangles with, of course, acute angles. So we first want to start off by looking at this triangle that I have drawn here, and I want us to see what the trigonometric values are. And I want us to see some connections here when if we're looking at, say, angle A versus angle B. So we're going to use the way that we define these trigonometric functions from the previous chapter, using words like opposite, adjacent, and hypotenuse. So we're going to define these trigonometric functions using the same words that we used in the last chapter, adjacent, opposite, and hypotenuse. So if I were to focus on just the angle A right now, and we were to find, what is the sine of A. So remember, sine is going to be the opposite side, which is 10, over the hypotenuse, which is 26. And this reduces to 5 over 13. And remember, if you forgot what those relationships are, write it out at the top. Write out that mnemonic, SOHCAHTOA. And we can use that to build everything else that we need. If I want to look at what is the cosine of A, well, cosine of A is going to be adjacent 24 over the hypotenuse 26, and we have 12 over 13. And if we were to look at the tangent of A, that's opposite over adjacent. So the opposite is 10, the adjacent is 24, and this ratio reduces to 5 over 12. All right, so let's leave that there for just a second, and let's change our focus to angle B now. And if I were to focus on the B, and I were to do the sine of B, so sine is still going to be opposite over hypotenuse, yet from this perspective, the opposite side is going to be 24. So this is 24 over the hypotenuse 26. This reduces 12 over 13. And if we do the cosine is going to be the side adjacent. So that's going to be for angle B, that's going to be 10 right here. So 10 over 26, which gives me 5 over 13. And, whoops. I don't know why my mind's trying to go to cotangent. That's not what I mean. Tangent of B is equal to 24 over 10, which is 12 over 5. Well, the two big things to notice here are what we have going on with the sine and the cosine. So for the sine of A, it's 5 over 13. Now that also happens to line up with the cosine of B being 5 over 13. If we look at cosine of A, that's 12 over 13, and that's the same thing as the sine of B being 12 over 13. So you've got sine and cosine being the same. So the sine for angle A is the same as the cosine for angle B. And the sine for angle B is the same as the cosine for angle A. So when we have the right triangle here, and you have these angles A and B, now these are not going to be where the right angle is, then you end up with this kind of relationship where the sine of A is equal to the cosine of B. And if we do the cosine of A, we get the sine of B. And it all comes down to the fact that these guys are complements of each other. So when I'm looking at A and I want to do the opposite over the hypotenuse, the opposite side is 10, the hypotenuse is 26. Well, from angle B's perspective, 10 is the adjacent side, and of course the hypotenuse is still the hypotenuse. So what is opposite to A is adjacent to B, which is why you have that connection between sine and cosine. Now you'll notice that for the tangent values, these guys are not equal, but you will see that these guys are reciprocals. So what we can see there, let me just add this a little bit over here. So the tangent of A is 5 over 12, which means the cotangent of A would be the reciprocal 12 over 5, which happens to be the same thing as the tangent of B. So you see there's that connection. You're going to see all these connections with the trig value, or the trig functions, and the co-functions. So you see that combining sine and cosine, see how those guys relate, tangent and cotangent, and then also secant and cosecant. Let's look at another example so you can just see it happen again right here. If I am, let's do this. Let me focus on angle A. So the sine of A, again, remember, opposite over hypotenuse. Sine is 9 over 41. And the cosine of A would be the adjacent 40 over 41. Now from these, even without us making anything brand new, we could find what the trig values are for angle B, because the sine of B should match up with the cosine of A, so that should be 40 over 41. And the cosine of B should be the same as the sine of A, which is 9 over 41. So sine of A is opposite over hypotenuse. But then the cosine of B uses the adjacent, which is still 9, over the same hypotenuse, which is 41. So we're starting to see some of the connections there. So taking this, that leads us to some nice statements that we have. And that comes down to the cofunction identities. Okay, and again, it's all about these guys being related to each other by being complements. Okay, A and B are complements of each other. So we can say the following. We can say that the sine of A is going to equal the cosine of 90 degrees minus A. Because again, these guys are cofunctions of each other. A and 90 degrees minus A are complementary angles. So as we were seeing in the previous examples, when the sine of A is looking at opposite over hypotenuse, then the complement, which would be angle B, would be using the adjacent over the hypotenuse. So the complement's adjacent side is going to be the original angle's opposite side. So that's why these guys are going to be the same. In much the same way, we can say that the cosine of A is going to be the sine of its complement. When I do the tangent, that's going to be the cotangent of the complement. Likewise, if I do the cotangent, it's going to be the tangent of the complement. The secant is going to be the cosecant of the complement. And of course, the cosecant is going to be the secant of the complement. All right, so we're going to take these guys, and in the next video, we're just going to use them to rewrite some of these trigonometric expressions. So hope you stick around for that.